Hi everyone. Before I walk you through the solution, I like to quickly introduce our team, KeenStack Mavericks. Together, we built the CMDB mapping assistant to address a very practical challenge in legacy ITSM migrations, making CMDB mapping faster, smarter, and more reliable. Let's start with the problem we are trying to solve. When an organization migrates from a legacy ITSM platform to ServiceNow, one of the most time consuming activities is mapping the legacy data model to the ServiceNow CMDB. A legacy platform may have hundreds or even thousands of fields, and every field needs to be mapped to the right ServiceNow class and attribute. Traditionally, this means spreadsheets, manual analysis, and a lot of dependency on CMDB and migration. It's slow, repetitive, and very easy to get wrong. To address that, we built the CMDB mapping assistant, an AI-powered accelerator that automates the first pass of this mapping exercise. The idea is simple. Give the assistant a legacy CMDB field catalog and let it analyze the data, identify the most appropriate ServiceNow CMDB classes and fields, and provide a confidence score for every recommendation. Instead of asking a SME to start from a blank spreadsheet, we give them an intelligent starting point. Let's see how it works. Here I have a legacy CMDB export containing asset classes and fields from a old ITSM system. I'm attaching that to the directly to a new import job record in ServiceNow. There is no special upload application or separate process here. It's simply a standard attachment on the import job. Here we have our import job record. The status is currently queued. That's intentional. As soon as the attachment is added, our processing pipeline detects the file and starts working on it in the background. There is no need for the user to manually trigger another process. This is the CMDB import class results. While that processing happens, let's look at the process of the results generated from an earlier job. So this is our class result table. Every class asset class, every legacy asset class, the accelerators adjust the corresponding ServiceNow CMDB class. It also provides a confidence score on the class point of view and explanation for the recommendation. This is important. We don't force the AI to make every decision with false certainty. When the match is weak and the result is explicitly marked as low confidence and sent for human review. So instead of hiding uncertainty, we are making uncertainty visible. Now let's go back to the import job. So here we can see the structured result generated by the mapping engine. The output contains the legacy field, the suggested ServiceNow field, the confidence information, and supporting analysis. This structured output is what allows us to take the AI recommendation and turn it into something that we can actually be reviewed and used as part of a migration process. Now we get to the most important part, the field result table. This is where we go from class level mapping down to the individual fields. Across the test catalog, we are generating more than quite number of individual field mapping decisions. Every row represents a field mapping decision. We can see the legacy source field and the suggested service node target field, the confidence tier high, medium or low, and whether the mapping needs additional review. The assistant can also retain alternate suggestions that it considered so a reviewer isn't just getting an answer. They are getting the recommendation, the confidence behind it, and the alternatives that we are considered. This is where we need deliberately keep a human in a loop. For example, a straightforward mapping happened. We can review and receive it then we can review the high confidence recommendations and all. But if a legacy field could reasonably map to multiple ServiceNow attributes, the assistant doesn't pretend that the answer is certain. Instead, it flags the mapping for review. That means the SME spends their time on the genuinely ambiguous decision instead of manually validating hundreds of obvious ones. Now let's look at the conversational side of the solution. I'm I have created all the already I have created the CMDB record, right? So please take a look on that. Instead of manually navigating through the process, we can ask the agent to work with the import job and perform the analysis. The first is analyze legacy CMDB catalog that kicks off the actual mapping analysis. The second is get import job status. This allows the agent to check whether the analysis has complete. And this is deliberately designed to be asynchronous. For a large legacy catalog, analysis can take some time. We don't want the agent to sit here waiting for a long running process and potential timeout. Instead, the agent starts the analysis, checks the job status, and communicates the actual state back to the user. If the job is still processing, it simply tells us that. That's a deliberately reliability decision rather than a limitation. And now see, we can see the input job picking up the results as they become available. The auto mapped count, missing identifier count are populated directly automatically. There was no manual data entry involved in generating these results. We started with a legacy spreadsheet attached to a import job, and the accelerator transformed that source catalog into structure confidence code CMDB mapping recommendations. And the approach isn't limited to a single legacy platform. We tested the accelerator across 4 enterprise ITSM platforms: Cherwell, Ivanti, BMC, and OpenText. Across those test catalogs, we processed several number of fields, with every field receiving an automated mapping recommendation. The confidence levels varied by platform, which is expected because each legacy system structures its data differently. Across the platforms, around 20 to 25 to 30% of mappings averaged high confidence, with the remaining mappings available for medium or low confidence review. The important point is that we are not replacing the SMEs, we are giving the SME a much stronger starting point. So the value of the CMDB mapping assistant is straightforward. Instead of starting a migration with a blank spreadsheet and manually mapping hundreds of fields, we start with the AI generated mapping baseline. We get class level recommendations, field level mappings, confidence scoring, alternate suggestions, and human review flags. That turns highly manual migration activity into an intelligent, repeatable process. Ultimately, the goal is simple: let AI handle the repetitive mapping work and let the experts focus on the decisions that actually require human judgment. That's our CMDB mapping assistant. Thank you.